Hello students, welcome to the physics class. In my last class, I have discussed about unit and dimension. Now, today's class, I will discuss the second part of the dimension. We will start with the principle of homogeneity, which says that every equation relating physical quantities must be dimensionally homogeneous. It means that two physical quantities will only be added or subtracted or divided only when their dimensions are same. Means if you are adding two physical quantities, it can only be added when their dimensions are same. The same rule follows for subtraction, division, everything. Okay, that means if equation I write q equals to w plus x, where q is the heat, w is the work done, and x is some unknown quantity, and I know the dimensions of q, w and x must be same. As I am writing q equals to w plus x, this equation is correct when the dimensions of q, w and x are same. So heat and energy both are having same unit and same dimension, that is m L to the power 2 T to the power minus 2. So q is also having this dimension, w is also having this dimension. That means x is also having this dimension. That means when the dimensions are same, then only you can add those physical quantities or subtract or multiply or divide. So that's why this principle of homogeneity says that every equation relating to physical quantities, here q, w, x, these are physical quantities, must be dimensionally homogeneous. Means the dimensions should be same. Okay, now use of dimensional analysis. First we will see, to check the correctness of an equation, we can use the dimensional analysis to check whether an equation is correct or not. In my last class, I have showed that. Again, I will be showing this one. Suppose if any one equation you take, like V equals to U plus 80. This one we have discussed in my last class. Today I will show you another one. Suppose V square equals to U square plus 2AS. Now this equation, whether it is correct or not, we can prove it from dimensional analysis. Let us check how. As you know, from the principle of homogeneity, an equation can be only correct when, or it can be added, the physical quantities can be added only when the dimensions are same. So if I can prove here the dimension of left hand side equal to the dimension of right hand side, that proves that this equation is correct. So the dimension of velocity, that is displacement by time, so dimension of V is L T to the power minus 1. Square is there, so I put square term. U is also initial velocity, so same dimension, L T to the power minus 1 plus 2. A means acceleration, that is L T to the power minus 2 into S means distance, that is L. Or left hand side comes as L square T to the power minus 2. This 2 gets multiplied, equals to L square T to the power minus 2 plus 2 into, you see, L square T to the power minus 2. So as you can see now, both the sides are having same dimensions. So that's why this equation is correct. You can try this with any other equation. You have to prove the dimensions of both the sides are same. So like this, we can check the correctness of an equation. Another application of dimensional analysis is that we can find the relation between unknown physical quantities. For example, I am showing you. Suppose time period of oscillation T. I want to find out the relation of time period of oscillation with, suppose it depends on mass, length of the spring and acceleration due to gravity. So I am now going to find out how this time period depends on mass, length and acceleration due to gravity. So for this, let us consider that time period depends with mass to the power of A. Means time period I can write like this. It depends on mass to the power of A by m square, m cube, m4, etc. Similarly, L to the power B means time period depends on the length to the power of B, and time period maybe depends to the cth power of G. Now together if I write these three equations, what I will get if I combine these three? So I will get T proportional to m to the power A, L to the power B, G to the power C. So T is depending on m, L and G in this way, that it depends the 8th power of m, bth power of L and cth power of G. Now if I want to remove this proportional sign and give it one equal sign, I have to put one constant. Here I am putting K. K is a dimensionless constant. Remember please, K is a constant which is dimensionless. So K into m to the power A, L to the power B, G to the power C. Now, what is the dimension of m? Dimension of m is this. Dimension of L and dimension of G. G means acceleration due to gravity. That means it has the dimension of acceleration which is L d to the power minus 2. Okay? And T, dimension of T is this. Got it? So I can write T equals to, dimensionally I write K into m to the power A, L to the power B and G to the power C. So I can write like this. Now see, here there is only T, that means there is no term of m and L. So I can write this side as m0, L0, T. Because m0 means 1, m to the power 0 means 1, L to the power 0 means 1. So what remains is T equals to K into, see, m to the power A. Now here L to the power B and here L to the power C. So L to the power B plus C and T to the power minus 2C. So I have multiplied and written. Now if I compare both sides, by comparing both sides what I am getting? I am getting, by comparing both sides, what I am getting? I am getting A equals to 0. Next, B plus C equals to 0 because I am comparing the power of M, L and T. So here A equals to 0. B plus C equals to 0. And what I am getting? T to the power nothing is there, means 1 is there. So minus 2C equals to 1. This I am getting by comparing. Now from this, C equals to minus half. Now from this equation, B equals to minus C. That means plus half. Because C equals to minus half, so minus of minus half means plus half, and N equals to 0. So I have got the values of A, B and C. Now if I put this in this equation, so what I get? T equals to, from this I am getting m to the power A, so m to the power 0, L to the power B. L to the power B means L to the power half, and G to the power C. Value of C is minus half, so G to the power minus half. Here K into, K term will be there. So I am getting K into m to the power 0 means 1, L to the power half means root over L, G to the power minus half means 1 by root over G. Got it? So if we take it together, it will come as A root over L by G. So So basically what we got, T equals to K root over L by G. Now the value of K cannot be found by using this dimensional analysis, but from experimental values it has been found that the value of K is 2 pi. So what we get finally, the equation of T, we get it as T equals to 2 pi root over L by G. This is the expression of time freedom of oscillation. So see, by using dimensional analysis we can also find the relation between unknown physical quantities. So this is another application of dimensional analysis. Next, another application. Conversion of units. Means in one system of unit, a physical quantity is there. If I want to express that in another unit, how it will become? So the change I will see. Suppose we all know about force. The SI unit of force is Newton, and CGS unit of force is dyne. Now I will establish the relation between Newton and dyne by using dimensional analysis. Let us check how. What is the dimension of force? Dimension of force is force equals to, if you have, in case you have forgotten, let me just remind you, mass into acceleration. So dimension of mass is m and dimension of acceleration is L t to the power minus 2. So together it becomes m L t to the power minus 2. This is the dimension of force. Now suppose in one system of unit, if you remember in last class I have told you that N1 U1 equals to M2 U2. One equation I have shown you here like this, where N1 is the numerical value in one system of unit and U1 is the unit of that system, and similarly N2 is the magnitude or value in another system of unit and U2 is the unit of that system. So now suppose SI and CGS I am talking about. So I am trying to find out 1 Newton equals to how much time. For this, so first I will see the dimension of force, M L t to the power minus 2. Now let us consider in one system the value of M L t be M1, L1 and T1, and in another system of unit the value of M is M2, L is L2 and T is T2. Okay? How are they related? So the dimension of force in one system of unit is M1, L1, T1 to the power minus 2. This is the dimension in one system, and in another system the dimension is M2, L2, T2 to the power minus 2. That is coming from this, ML to the power minus 2. So in one system this and another system this. So this is N1 and here is N2, the value. Now if I try to find out the value of N2, I am trying to find out the value of N2. So N2 is equals to N1. See, I will be dividing this one. Check whether I can write like this or not. M1 by M2, I can write this, into L1 by L2 into T1 by T2 to the power minus 2. Okay. If you have any confusion, let me just clear this one. This is T1 to the power minus 2 divide T2 to the power minus 2. Clear? So T1 by T2 to the power minus 2 whole to the power minus 2. So from this we are getting this. So I am just writing here. Clear? Now what I will do, M1 by M2. M1 is in SI system. These ones are in SI system and the 2s are in CGS system. So N2 equals to N1 into M1. M1 means how much? Suppose 1 kilogram I am talking about. So kg unit and M2 is in gram. Length in meter and in centimeter. And T1 and T2 is second and second. I hope it is clear. I have just put the unit of M1, M2, L1, L2, T1, T2, where M1 is the unit of mass in SI system, which is kg. In place of M2, I have put the unit of mass in CGS system, gram. In place of L1, I have put the unit of length in SI system, that is meter. In place of L2, I have put the unit of length in CGS system, that is centimeter. Similarly for time, both are second in SI and CGS, so I have put that here. Now this one, I am coming here. From the last line, you see, so N2 is equals to N1 into kilogram by gram, means 1000 gram by gram, here means 1 gram, so 1 gram. Now meter by centimeter means 100 centimeter, pardon me, by 1 centimeter, and in second that cancels out. So what is coming? N1 means 1 Newton. I am trying to find out the relation between 1 Newton equals to dash time. So in place of N1 I will put 1. This comes 10 to the power 3 and this comes 10 to the power 2. So the value of N2 is coming 10 to the power 5. Correct? So now the equation, if you remember, I have written N1 U1 equals to N2 U2. So in case of force, in U1 stands for the unit in SI system, that is Newton. Value of N1 is 1. So 1 Newton equals to value of N2 10 to the power 5 and U2, that is the unit of force in CGS system, time. So it can be shown from here by using dimensional analysis that 1 Newton equals to 10 to the power 5 time. So there are many more applications like this. You can practice it from your textbook, these calculations. But there are also some certain limitations of dimensional analysis. One of the most important limitation is that, drawback is that it cannot measure the value of the dimensionless quantities. Like in that formula, the first formula, 2 pi root over L by G, the dimensionless constant K, it was unable to find the value of that. So only by experiment you have to find that value. Okay. So hope the things which I have discussed today you have understood. Go through your textbook, practice it from your textbook, and if you have any problem, you please get back to me. I will definitely try to solve that. In my next class, I will start another chapter. Till that time, stay safe. Bye-bye.